Hi class, this video is going over mole conversions from your molar mass and mole conversions homework assignment. There's another video that has molar mass calculations. This one's just going to focus on the mole conversion section of the assignment. So it's a little bit harder because you do have to calculate the molar mass in addition to doing the mole conversions. You need that to calculate these answers. So I'm going to do a few problems, kind of like one of each type. So it might take a little bit of time because we will be doing molar mass as well. But if you're having trouble with this, hopefully this will help you out. So the first question I want to do is number 9. Find the mass of 0.89 moles of calcium chloride. To do these conversions, you'll probably want to refer in your notes to this conversion chart where we have how we could convert from mass to moles or particles, and this you can use this any direction. You can enter and exit at any point of this. So depending on what the question's asking us, we'll be using different paths on this conversion sheet. Okay. So the first one is asking us to find the mass, and we are given the moles. So using our sheet here, we are at this point with the 0.89 moles, and it's asking for mass. So we want to go from here to here. So in order to do that, we're going to need the molar mass from the periodic table of calcium chloride. Okay, so first I'm going to do that calculation, calculate the molar mass, which is what we did in the other video, so I'm going to go pretty quickly over this one. But we're going to do calcium is 40.08. And chlorine is 35.45. And we have 2 of those. So I'm going to do this calculation. (110.98 grams). So that's the molar mass that I'm going to need to set up this problem. Okay, so I'm going to start out with the moles of CaCl2. So we're going to start out with that number, 0.89 moles CaCl2, and then I'm going to need the conversion factor. So to go here from moles to mass, I can use the molar mass that I just calculated, because remember, that's grams per mole. So here I have moles in the top, so I'm going to do moles in the bottom. The mass goes in top, and this is the mass. And anytime you calculate the molar mass from the periodic table, it's always going to be for 1 mole, and that's shown in your conversion sheet as well. Okay, anytime you take numbers off the table, those are for 1 mole of that element, and in this case for the compound, since we're adding up all the elements. So now our moles cancel. We get grams, which is good because we wanted a mass here. So now, just like your regular dimensional analysis problems, we're going to multiply the top numbers, divide the bottom numbers. So 0.89 times 110.98, because it's in the top, equals this number. We are allowed the number of significant figures that are in the number given to us. We're going to treat the molar mass as an exact value conversion factor. So we get 2 sig figs here. So 1, 2, but it's followed by a 7, which is greater than 5. So this is going to round up to 99 grams. Or you could write 99 grams CaCl2. Okay, so that's the first one. Next one we'll do is number 11, determine the number of moles of C5H12 that are in 362.8 grams. So we are starting this time with grams, so we have a mass, and we need to figure out the number of moles. So we're going the other way, we're going here to here. But again, we're going to need the molar mass. So why don't we go ahead and calculate that. We have 5 carbons. Each carbon has a mass of 12.01. We have 12 hydrogens. Each hydrogen has a mass of 1.01. Calculate that. 72.17 grams. That's our molar mass. And we're going to start with the number that they give us. So this 362.8 grams. And this time we want an answer in moles. So we want to cancel the grams out. So this needs to go in the bottom this time of our conversion factor to cancel, and it's this number here. There we go. And that's always going to be for 1 mole. So remember, this is in our conversion sheet. It's always for 1 mole. So this time we are using this version of the conversion factor with the mole on top. Okay, so our grams cancel. We get moles as our unit, so let's calculate this. 362.8. This time we're dividing this number because it's in the bottom. 72.17. All right, and for sig figs, we are allowed the number of sig figs in the number given. 1, 2, 3, 4 sig figs here. So we get 1, 2, 3, 4 sig figs. It's followed by a 0, which is less than 5. So that is the number with rounding, and that is moles C5H12. Okay, so that's that one. We'll do a couple more, a little trickier ones down here. Number 15, how many moles of fluorine are in 2.24 grams of OF2? This one's very tricky. But think about what it's giving us. It's giving us grams, and we want moles. So we have a mass, we want moles. But the tricky thing here is that it's asking for moles of fluorine, not moles of OF2. So we really need to think about this. So what we can do is, first, we want to figure out how many moles of OF2 we have. So we'll do that part first, and again, we're going to need the molar mass to do that. So molar mass of OF2 is going to be 16.00 grams plus 2 times 19. .00 grams. So that's our molar mass. So let's first convert the grams of OF2 to moles of OF2. That's a good start. So we did this before. We need to put the grams in the bottom, so this number, 54. And we took those numbers from the periodic table, so it's always going to be 1 mole. Okay. So now our grams of OF2 cancel. If we stopped here, we would have moles of OF2. But what the question's asking us for is moles of specifically fluorine. So what we need to do now is think about what OF2 looks like and what is the relationship between fluorine and OF2. And you can just do that by looking at the formula. I have built a little OF2 just so we can have a little visual here. But this is the same thing, and you can just use the formula to do this. But if we had a single molecule of OF2, this would be 1 molecule, and in this 1 molecule, we would have 2 atoms of fluorine, and we can see that in the formula. 2 fluorines for every 1 molecule of OF2. So what that means is that if we had 1 mole of OF2, remember, top and bottom of a conversion factor have to be equal. If we had a mole of these things, how many moles of fluorine atoms would we have in that mole? The ratio here is that there are 2 fluorines for every 1 molecule. 2 atoms of fluorine for every 1 OF2 molecule. So that means that if we had a mole of these, we would have 2 moles of fluorine. So there are 2 moles of fluorine for every 1 mole of these molecules. So now our moles of OF2 cancel, and we're going to get an answer in terms of moles of just fluorine. So when we calculate this, now we can see our units will give us the right answer. When we calculate this, just like any other calculation, 2.24 divided by 54, because it's in the bottom, and then we're going to multiply it by 2, because that's in the top, and that will give us an answer of moles of fluorine. Sig figs, same thing. We're going to look at the 2.24, so we can have 3 sig figs. Zeros on the left, never significant. So 1, 2, 3, and then it's followed by a 6, which is greater than 5. So we're going to have to round this up. So the 9 gets rounded up, which means this gets rounded up to a 3. This is a tricky rounding one. This is good practice. So it's going to be 8, 3, and then to make one more significant figure, we need to add a 0. And the units are moles of fluorine. Oof, that's a tricky one. If you can get that, you are in good shape. Okay, we'll do one more tricky one. Number 16. How many total atoms are in 0.78 moles of N2O? So another tricky one here. It's asking for total atoms, and we're starting with moles of N2O. So for this one, we're going from moles to a type of particle once atoms, right? So we actually don't need the molar mass to do this conversion. We just are going to need Avogadro's number. So we're starting with moles of a molecule, N2O, and we're trying to convert that to total atoms. Not the number of molecules, but the number of atoms. So to do that, we'll start out with the number given. And there's a couple different ways you can do this. You could first convert the moles of this into the moles of atoms, or you could go from moles of this to moles of molecules, and then to atoms. So I think that's what I'm going to do. I'm going to first break this down and convert moles into particles, which in this case, the particle of this, of N2O, is molecule. This is a molecule. So what we can do is we can convert 1 mole of N2O is equal to 6.02 times 10 to the 23rd, in this case, molecules. Because N2O is a molecule. Okay, so now with that conversion, we get molecules of N2O. But what the question is asking us is for total atoms. So now we have we can look at a single molecule of N2O. If we look at this formula, how many total atoms make up one of these molecules? Well, there are 2 nitrogens and there's 1 oxygen. So in total, we have 3 atoms that make up this molecule. So if you have 1 molecule of N2O, this needs to go on the bottom because it's in the top here. Within 1 molecule of N2O, there are 3 atoms. These are equal. Top and bottom are equal. So now our molecules of N2O cancel, and we're going to get an answer in terms of atoms, total atoms. So when we type this into the calculator, 0.78 times, remember to type in Avogadro's number, use the EE button, so 6.02 EE, and then 23 times 3, because that's in the top. We're going to get this big number. We're allowed to use 2 sig figs only. So 1, 2, so it's going to be 1.4, and then the 24 there means times 10 to the 24th power, and that is atoms. That's the total atoms. Right? And that is the final answer for that last problem. That is a very, very tricky problem. So I'm sure you'll have more questions on that. Let me know in class how we can help you go through kind of these last 2 problems if you're still having trouble with this.